A SpaceX booster just slammed into the ocean at 100 miles an hour. 13 engines were supposed to fire, only a fraction lit in time. The booster never slowed down. It hit the water, hard, and the tanks ruptured on impact. But here's the twist. Just minutes earlier, the Starship riding on top of that same rocket did something SpaceX has never pulled off before. It fired its engine in orbit, and it worked perfectly. So while one half of the mission ended in wreckage, the other half just proved something huge. And now, Elon Musk himself has confirmed what happens next. SpaceX is going after the catch. Stick around, because what he said changes everything for the next launch. Let's rewind the clock. 2 days before this launch even happened, something strange took place on the pad. The booster lit its engines, and within seconds, it shut them all back down. No explosion, no fire, just silence. That silence should have scared you more than an explosion would have, because a silent shutdown means the computer saw something it didn't like, and it made a decision in a fraction of a second. Out of 33 engines, 4 failed to light. SpaceX has a rule for moments like this. Lose more than 2 engines on the pad, and the launch is over before it starts. 4 was too many. So the countdown stopped cold. The rocket rolled back to the hangar. Engineers pulled engines off the booster, one by one, and swapped them for new ones. And for 2 days, nobody outside SpaceX knew why. Here's the part that should really bother you. 9 days earlier, that exact same booster fired all 33 engines for almost a full minute during a static fire test. Every single one worked. So what changed between a flawless minute-long burn and a failed launch just over a week later? That question sat unanswered until the day of the actual flight, when SpaceX finally explained it, and the explanation was almost impossible to guess. The enemy was already inside the engine. The problem wasn't fuel. It wasn't the weather. It wasn't a software bug. It was ice. Stop and think about that for a second. This is a rocket engine. It burns methane and oxygen at temperatures hot enough to melt steel, and somehow ice built up inside it anyway. So how is that even possible? When you burn methane, you get 2 things, carbon dioxide and water. That's basic chemistry, the same reaction that happens in your kitchen stove. Now put that water vapor inside a system that's also storing liquid methane at minus 160 degrees Celsius. That's colder than the surface of Mars at night. Under those conditions, water doesn't stay a vapor for long. It freezes instantly. And where does that ice end up? Inside the turbopump. The turbopump is the heart of a rocket engine, a turbine spinning at tens of thousands of revolutions per minute, forcing propellant into the combustion chamber at enormous pressure. It has no room for error and even less room for ice. A single ice crystal in the wrong place can jam a valve, unbalance a turbine blade, or block a fuel line entirely. SpaceX confirmed it. The 4 engines pulled off the booster all showed small traces of ice contamination. Not a lot. Just enough to throw a system that precise completely out of balance. Now here's the question nobody's really asking, and it's the one that actually matters for the future of this rocket. Why was there ice in the system at all? The answer traces back to how SpaceX pressurizes its fuel tanks. Instead of carrying separate pressurization gas, they've been using autogenous pressurization. They burn a small amount of propellant and pump the exhaust gas back into the tanks to keep them pressurized. That exhaust gas is exactly the mixture we just talked about, carbon dioxide and water vapor. Feed that byproduct back into a cryogenic tank often enough, and eventually, ice starts building up somewhere it shouldn't. This isn't a one-time glitch. It's a byproduct of the exact system SpaceX is relying on to make Starship reusable. And that means it's not going away on its own. If SpaceX wants to fly this rocket again in hours instead of weeks, which is the entire point of Starship, they need to solve this permanently. Not by swapping engines after every flight, but by keeping ice out of the fuel system in the first place. Keep that in the back of your mind, because everything you're about to see happened while that unsolved problem was still sitting inside this exact rocket. Liftoff and the first warning sign. 2 days after the aborted launch with new engines installed, SpaceX tried again. This time, all 33 engines lit together. The most powerful rocket ever built left the pad under more than 18 million pounds of thrust, roughly twice the liftoff power of NASA's own SLS moon rocket. But less than a minute into the flight, something odd showed up on camera. Around the 47-second mark, independent footage from NASA spaceflight.com caught a brief burst of flame jetting off the side of the vehicle. It wasn't visible on SpaceX's own broadcast. It didn't show up as an engine failure in the telemetry. So what was it? There are two competing explanations, and neither one has been confirmed. One possibility: something physically broke off the rocket and burned up instantly in the exhaust plume. The other, based on the color of the flame, a fuel-rich combustion event, meaning one engine ran slightly off its ideal fuel-to-oxygen ratio for a split second before correcting itself. Either way, the booster kept flying. Whatever it was, it didn't stop the ascent. The real test was still ahead. At around 2.5 minutes into the flight, Starship and its booster reached the point of separation. This is one of the most violent, most visually insane moments in the entire flight. And it's also where the story starts splitting into two completely different outcomes. Here's what physically happens. The booster has to flip itself around 180 degrees, while the Starship on top of it is simultaneously trying to light its own engines and pull away. For a moment, both vehicles are firing engines at nearly the same location in the sky. Starship's exhaust plume is hitting the side of the booster directly. The booster's own engines are relighting into that same superheated exhaust cloud. Picture two flamethrowers pointed at each other at supersonic speed. That's not an exaggeration. That's literally what the footage from the ground showed observers watching from Boca Chica. But here's what actually matters. The booster survived it. All of its engines relit successfully through that fireball. It performed its boost-back burn exactly as planned, correcting its trajectory to bring it back down over open ocean instead of the launch site. For a moment, it looked like everything was going right. This is where the story turns. As the booster fell back toward the ocean, it was descending at roughly twice the speed of sound. To survive that, it needs to relight its engines one more time, in a maneuver called the landing burn, and slow itself down to almost a complete stop right before it touches the water. 13 engines are supposed to light for this burn. Watch the telemetry closely, and you'll see something go wrong almost immediately. Not all 13 ignite, and a couple of the engines that do light shut back down partway through the burn. Do the math on that for a second. This booster needed every one of those engines working together to cancel out its speed and time. Losing even a few of them doesn't just slow the process down, it changes the entire outcome. The booster kept decelerating, but not fast enough, not even close. It hit the ocean at approximately 100 miles an hour, full speed effectively. According to the flight data, if that burn had simply started a few hundred meters earlier, the booster could have made a soft, controlled splashdown instead. Instead, the propellant tanks ruptured on impact, and observers nearby reported a blast of fire on the water's surface. This is hundreds of tons of rocket hitting the water at highway speed, and the difference between a soft landing and a violent one came down to a matter of a couple hundred meters, and almost certainly that same ice contamination problem from earlier resurfacing during the one maneuver where there was zero room for error. While the booster was failing, something else was succeeding. Here's where most coverage of this launch gets it wrong. They treat this as a failure story. It isn't. It's two different stories unfolding on the same rocket at the same time. While the booster was falling toward its rough ending, the Starship riding above it had already separated cleanly, and its engines were running perfectly. No ice contamination, no shutdowns. Just after the 8-minute mark, Starship reached orbital velocity, and then it did something this rocket has never successfully done in a full orbital environment before. It deployed satellites, 20 of them. Real, full-size Starlink version 3 satellites, the new generation that's physically too large to launch on a Falcon 9. This was their first time ever flying on Starship, and their first real test in space, even though their orbit was intentionally decaying, meaning they were never meant to survive long. Their entire job was to prove the deployment mechanism worked and to help SpaceX inspect the ship they'd just ridden on. Some of those satellites carried something extra: cameras and lights. SpaceX deliberately waited until Starship crossed into Earth's shadow before deploying them, so those cameras could photograph the ship's heat shield illuminated against total darkness, capturing exactly what it looked like before re-entry, for direct comparison against whatever came after. Then Starship did something almost theatrical. It performed a slow, full rotation in space. Engineers call it a pirouette, turning itself in every direction so those satellite cameras could capture the entire heat shield from every angle before the satellites drifted away for good. While this was happening, something strange showed up in the footage. small blue points of light, visible near the deployed satellites. The likely explanation: those satellites were firing their ion thrusters for the first time, running on battery power, glowing blue in the vacuum of space. Nobody's confirmed it yet, and SpaceX hasn't released any of that camera footage publicly, a detail worth remembering when we get to what happened after splashdown. Now here's the real headline of this entire mission: the one moment SpaceX needed more than any other, and the one thing that failed on the previous flight: relighting an engine in orbit. This sounds simple. It isn't. On the ground, a rocket engine benefits from atmospheric pressure and gravity, helping to feed propellant smoothly into the combustion chamber. In orbit, there's almost none of that. Propellant floats. Fuel lines have to be pre-chilled precisely, or the engine can misfire. Or worse, not fire at all. And if it doesn't fire, Starship becomes a piece of uncontrolled space debris the size of an office building, orbiting the Earth with no way to bring itself down safely. Eventually, gravity would pull it back into the atmosphere somewhere unpredictable, potentially surviving re-entry and crashing down anywhere on the planet. That's not hypothetical. That's exactly the scenario SpaceX has been trying to avoid for multiple flights in a row. So, watch what happens next. Starship chills its engine down, venting gas that interacts with the razor-thin atmosphere 140 kilometers up. Then, ignition. And it's not subtle. The plume was bright enough to be visible from the ground, to observers watching from South Africa, at an altitude where there's barely any air at all. The exhaust gas exits the engine at extreme velocity, then slams into what little atmosphere exists up there at an even higher relative speed, creating a glow you can see with the naked eye from the surface of the Earth. It worked. Clean. No hesitation. No failure. This is the single most important technical achievement of the entire flight, and it's the reason everything that came after was even possible. Coming home, and the landing nobody expected. With the relight confirmed, Starship began its descent back into the atmosphere over the Indian Ocean. Re-entry is normally the most dangerous 10 minutes of any Starship flight. This time, it was almost boring in the best possible way. The ship performed its banking turn, then transitioned into its signature belly flop descent, monitoring for tile damage the entire way down. Camera views showed no major missing sections of heat shield, and nothing suggested the structure had been compromised. At around 1 kilometer of altitude, Starship flipped from horizontal to vertical, lit its landing engines, and began its final descent toward the ocean's surface. The same way it would during a live tower catch attempt, and then it touched down and fell over onto its side exactly the way it's designed to during an ocean splashdown test. Here's what should have happened next, based on every previous flight: an explosion. Starship is roughly the size of a 20-story office building. When something that large tips over, the structure typically can't handle the sideways stress, and it tears itself apart. It didn't happen this time. There was some fire from venting excess propellant, but no explosion, no structural collapse. Just a massive rocket, sitting intact in the ocean, tipped onto its back. And that accident, because that's really what a controlled tip over into open water is, turned into the biggest engineering gift of the mission. With the ship lying on its side, its belly, the entire heat shield, was exposed directly to the sky and to the cameras still recording from inside. Engineers got to see something they normally never get: a full, unobstructed view of exactly how the heat shield held up, tile by tile, immediately after flight. Sazet. And they found something worth investigating. Streaks running across sections of the heat shield, almost all of them starting at the edges of individual tiles, on the leading edge where atmospheric gas would hit hardest during re-entry. That pattern suggests hot gas was working its way underneath the tiles during descent, lifting material out from beneath the surface. Some of those streaks appeared to wash away easily once seawater hit them, which raises its own question. Is this cosmetic, or is it a sign of a deeper weakness in how these tiles are sealed at the edges? Nobody outside SpaceX has that answer yet, but it's now sitting on camera, in high resolution, waiting to be studied. The detail everyone missed. While engineers pore over that heat shield data, there's a smaller, stranger detail worth pointing out. Even after tipping over into the ocean, Starship kept transmitting its position back to SpaceX's servers for hours, while partially submerged. Its Starlink antenna, the system it normally uses to talk to satellites overhead, was now pointed straight down into the water, and it was still somehow maintaining a connection to the outside world. Nobody's fully explained how. It's a small mystery buried inside a much bigger success story, and it hints at something SpaceX hasn't said publicly. A level of redundant connectivity on this vehicle that goes further than most people realize. So, here's where everything converges. Same rocket, same day, two completely different endings. The booster, the part that had already flown successfully before, the part that should have been the more predictable half of the mission, came apart on impact, brought down by a problem SpaceX has known about for weeks and hasn't fully solved yet. Starship, the part carrying all of the newest, least tested technology, the part that had never relit an engine in orbit before, the part everyone was most worried about, did everything right. Orbit, deployment, relight, re-entry, survival. And that result is exactly why Elon Musk's statement, released alongside the mission review, matters as much as it does. Musk confirmed that unless the mission data review turns up a problem nobody's caught yet, SpaceX intends to attempt something it has never done successfully with this generation of ship. Catching Starship out of the sky with a launch tower on the very next flight. Notice what he didn't say anything about. The booster. There was no announcement, no confirmation, no timeline for solving the ice contamination problem that just caused a rocket the size of an office building to slam into the ocean at highway speed. That silence is its own kind of answer. Which raises the real question heading into the next flight. Can SpaceX prove that Starship's success wasn't a lucky exception? And can they fix the exact same ice problem that's now failed twice before it cost them a booster they actually needed to bring home? The data is clear. One system failed, one succeeded, and that gap decides the next flight. I'm Adrian at the Space Brief. If this analysis was useful, like, share, comment, and check the screen now.